Hello! So today we are going forward with the chapter 2 of the guide. Last time we have seen the first part, so now we're going to finish it. I think it's better to go through this part of the guide on a live coding session instead of looking to the text of the guide. In this way, I can show you also a couple of little variants. So for example, here we have the class point with data, but also data.addList. In this way, instead of having to define the list of points in another declaration, we can just use point.list to talk about the list of points wherever we want. Then animal, we have data, I have the list, why not? So we can have lists of animals. And we have the var point location, the capsule point.list path. We have the mute method move, as we have seen, that called the remove left path capsule mutator. We have the method here in line 14 and 15 that is used to generate the capsule mutator. And then we added those two new methods here. A read method has arrived, and we will see the read modifier in a moment. The idea is that it can work on both immutable and mutable objects. And it's just asking if this .path is empty. And then a method will never arrive that checks if the animal has not arrived yet, but there is no modifier in front of this method. So implicitly, we have the im modifier, so this method only takes in input immutable animals, so if they have not arrived right now, they will never arrive, because they can't be mutated. And then, here I have some code where I can show you all the possible modifiers. So we can recap the modifier that we've seen, and then I can go forward and show you the other ones. So we have a 0, 1, and 2 points that are useful to define stuff. And then here very explicitly I'm writing mute animal dog mute. It's an animal in location 0 and in path 0, 1, 2, 1. So it's going to start at 0, then go in 0, in 1, in 2, and in 1. I have a dog immutable created with exactly the same expression, but defined as an im animal. And this is a little bit surprising maybe to you. You have seen the immutable points and the mutable animals. And so you may be under the understanding that each class just has a specific kind of objects. Point only have immutable ones, and animals only have mutable ones. But this is not the case. While there is no way to have a mutable point, we can have animals of all kinds. And in general, in 42, you can always have an immutable version of anything that you can instantiate in any way. The idea is that this works with the concept of promotion. To understand the concept of promotion, let's look to the line below. You can see here we have exactly the same expression again, and this time is assigned to a capsule animal. But again, the factory of animal returns a mute animal. So how can we assign it to a capsule? Well, the idea is that the type system look at this expression and see that it's a method call that returns a mute and doesn't take in input any mute. You see, this is im, this is im, this is im, this is im, this is im. So this whole expression doesn't take in input any mutable variable from outside, but it's still returning a mute. Since in 42 we don't have any form of static mutable variables, if you don't take any mute in input, but you still produce a mute, it means that the whole mutable reachable object graph from the result must have been created internally by the expression. And so the type system can promote the mute animal to a capsule animal. Then a capsule variable, a capsule local binding, can always be assigned to either a mute or an im. And so here in line 28, we have that the expression is first promoted to capsule and then assigned to im. Again, if we wanted, we could avoid any kind of type annotation here, because the factory gives you a mute animal, so you don't need to repeat it. Here, we could write animal, because im is the default modifier. Or we could trust the inference to infer animal and just write im. And same here, we could just write capsule. Then let's see which other kind of modifier we have. We can have a class animal, Oh, what is a class animal? We have seen the keyword in front of the methods when we declare a class method as a method that can be called just on the name of the class. But you know, methods are called on a receiver, the thing before the dot. And so this receiver needs to be an object. And so in 42, we have the concept of a class type that stores kinds of instances of a certain class that are representing the class itself. So here you can have a class animal concept, equal animal. It looks reasonably mysterious, but the idea is that animal, the constant animal, is of type class animal. While here we have different instances of animal that are of type mute animal, im animal, or capsule animal. So animal, the concept, is an instance of the class animal of type class animal, while our dog mute is an instance of the class animal of type mute animal. And then there are the new modifiers that we haven't seen yet, and so we're going to look at them right now. Length. Animal dog length equal dog mute. So length is a modifier that gives you the permission to modify the object, but not the permission to alias it for long-term reuse. And we will see in a couple of minutes a good example that explains this. And then we have read. And read is a very commonly used and important modifier in 42, albeit not as much as im and mute. And it's the common supertype between mutable and immutable objects. This means that we can assign dog im, dog mute, and dog length to read bindings. So here we see you have dog read 1 equal dog im, dog read 2 equal dog mute, and dog read 3 equal dog length. And they all are of type read animal. So if you don't know what type of animal you have to work with, you can just declare your binding to be a read, and you will be able to act flexibly on it. On the other side, you will not have any guarantee on what the rest of the program can do with that animal. In particular, let's compare this with immutable objects. When you have an immutable object, you know that no one else can mutate it. No one can mutate it. You cannot mutate it, but the rest of the code also cannot mutate it. So if you have a reference to an im, if you have an im animal, you cannot mutate the animal, but you also have the guarantee that no one else can break your assumptions and mutate that animal. While if you have a read animal, then you cannot mutate the animal, but someone else may be able to do it. For example, here, dog read 2 actually refers to a mutable dog. This means that when we call dog mute here in line 35, we could observe a change in our dog read 2 before and after that call. So the variable is observed as if it's changing behavior. You know, the reachable object graph is changing. But we cannot use that reference to change it. So here I'm showing which kind of methods we can call on those references. So on dog mute, I can call move because it's a mutable method. On dog length, I also can call move because this method doesn't take any other parameter mute, so it cannot make any aliasing between this existing dog and other objects. If I were to try to call dog read 1 or dog read 2 or 3 dot move, I will get a type error. Let's try. I press run. I go to the errors and we see an error. Incompatible modifier for method move. We will need a length or a mutable as a receiver. If you have dog read 1, you can still call the has arrived method. And since read can be initialized with both mute, im, length, capsule, you will be able to call has arrived on a wide variety of kinds of objects. On the other side, the method will never arrive can only be called on our dog im. Now you may wonder, what is that symbol? Well, in most programming languages, when you write just a sequence of statements, you can call any method call at top level. And if this method is returning a value, an important value, you may just forget to put this value in some variable and use it. So you may get confused about what is the behavior of this method, because if the method returns a value, it's probably important. So has arrived actually returns the boolean, and so 42 is telling me, hey, what are you doing with it? You need to do something with this return value. And so in order to silence this warning, you have to put it in some local variable. And if you don't care about the name of your local variable because you're never going to use it again, you can just call it underscore. So it's like an unnamed local variable. And in this way, we are clearly telling, I know that there is a return type and I purposely choose to ignore the result, instead of accidentally, as it happened in like so many other languages. So, as you can see, only dogim can be used to call will never arrive. If I were to try to call it on dog mute, I will get a different error message. Incompatible 45 from method call. For method will never arrive, the receiver need to be exactly immutable. Now, what can I do with my animal concept? With my animal concept, I can call all the class methods of animal. So in this case, the factory. So here I can make another dog. And so if I run, I get my printout for my other dog. This is important when we will introduce subtyping, where you will be able to pass different kinds of class animal by relying on inheritance. So, to recap, on a mutable dog, you can call the mutable methods. On an immutable dog, you can call the immutable methods. And on a class dog, you can call the class methods. So, this is indeed a little bit different from the general idea of object-oriented class-based languages, where the class defines all the methods that can be called on all the instances of a certain type. Here, instead, the modifiers work as a filter. Depending on the specific type of the receiver, only a subset of the method of the class are available to be called. Let's explore more in the detail the concept of length and read. Length and read are hygienic modifiers. They can prevent other code to do sneaky behavior by saving the reference inside their own state, or by injecting some mutable object that they control under the state of the length. So let's make an example, okay? We have a trusted piece of code, do stuff, to take a mute animal dog and a mute untrusted you. And the idea is that untrusted, it's library code. We don't control it. Or maybe our software, it's a big open source project and a lot of people from around the world that we don't really know or trust too much are writing code to be integrated in our project. And so we don't really know what this untrusted code is doing. So let's say that is a library, for now. And we do something with it, and then we call u.goToRoam that should simply check if our animal is eventually going to roam. And we pass our mute animal dog to this call. And then we look to our untrusted, and the first version looked just like this, It was taking our animal and it was just doing something to compute if the animal was going to roam. For example, it was exploring the path in order to check if the animal was going to a point that was near enough to the city of Rome. And at the time, maybe, this was even taking a read animal, thus promising that it was never going to mutate our animal. However, after a while, this library gets updated, and we don't just re-review all the code of all the libraries we import every time there is a new version. So what can be happening? What terrible thing can happen? Well, look at this. You can have a list of animals hidden into our untrusted object, and the method goToRoam could now take a mute animal, and it will still work in my context above, and then it can add the animal to the right of this list. And who cares? Well, it's actually very important, because this means that after I've done the call, the untrusted code is actually keeping control of my animal. And in any moment, surprisingly, this untrusted code may mutate it. And so I have my code where I think I have my animals under control, and they get broken in some way. Now, if I keep my animals well encapsulated, this cannot possibly happen anyway, but as we have discussed, there are real cases where we have to risk it and use mutable animals for various reasons. And so, it seems like in that case, we cannot use the library code that we don't control. Read, let's say, come to our rescue, because if the library were to take a read animal, then this code will never compile. So, but the animal here, we said, it's taking a mute. Well, it was taking a read in the past. So what we can do is that we can define a read animal read dog equal dog, and then we can pass the read dog. In this way, we are explicitly reducing the permissions on our object in the call side, so that if the library gets updated and requires now a mute dog, well, our code stopped compiling, and so we discover the problem before we get an actual bug, And so this is useful because read cannot be saved. Here, if we had read and we take the exposer for our hidden list and we try to add, well, we cannot add a read element to a list because we cannot update a field with a read in 42. So, not happening. We can use add to add an immutable animal, or #add to add the mutable animal. But there is no way to add a read one or a length one. Let's say that we want the semantic of our goToRome method to actually move the animal until it reaches Rome. But we still want to prevent that the untrusted code can save our animal for long-term reuse. What we can do is to require the library to take a length animal. And now, here again, we can have a length dog, and in this way we are giving these untrusted chunks of code the permission to mutate our animal, but not the permission to save it for long-term reuse. Okay, so this is all I wanted to show you today. See you in a few more days for Chapter 3.